Alison, and I am going to make you fall in love with Polyhedra. Get it? The pun was like solids, Polyhedra. Okay, anyways. So what is a polyhedron? Well, a polyhedron is a solid in 3 dimensions with flat polygonal faces, straight edges, that was another pun, and sharp corners or vertices. So for example, you have here your regular tetrahedron, your rhombicubic octahedron, your hexagonal antiprism, and your biluna birotunda. Stuff you should have learned in high school geometry, obviously. So I am in love with these little shapes, and it's easy to see why, because I'm not the only one. They've been used in art and architecture and film for centuries, from M.C. Escher to Star Trek to Dungeons & Dragons. They're beautiful and symmetrical and so simple and yet strangely alien to us. But there's also another reason that I like them. And it has to do with an obscure Japanese media franchise that some of you may know about. It's called Pokemons. It's kind of weird, but it's not. You might think that it's kind of silly, but it's really not, and I'll show you why. Both Polyhedra and Pokemon have a lot of hashtag data associated with them. They have Polyhedra have different, and Pokemon have different types. Polyhedra have different symmetries. Pokemon have different like egg groups and movesets, and Polyhedra have like nets and stuff. They both evolve. So Polyhedra, you can transform them like into each other through a series of operations, whereas everyone knows about Eevee. And finally, there's like a buttload of each of them. This is only the first generation of Pokemon. They keep adding new ones, and this is only like a subset of the convex Polyhedra. So with this in mind, like everyone knows who Pikachu is and who Charizard is and Mudkip or whatever the new one is. I don't know, they're on generation like 20 or something. But no one knows about like our poor tetrahedron or our poor biluna birotunda. So since I love these shapes so much, I wanted to show the world the beauty of these polyhedra and their relationships to each other. And I wanted to do it the only way I really knew how to: interpretive dance. Just kidding, I'm gonna code. So the first attempt at doing this was in May 2015. And back then, there was a really popular library called D3 and a really popular CSS library called Bootstrap. So it's like, I'll play with it. But I also need to like render them in, because they're 3D figures, I need to render them. So I used a library called X3DOM. And what it is it lets you, it's essentially SVG for 3D. It allows you to type in nodes, 3D nodes and entities and objects as XML, and then it'll take care of all the rendering for you. And this is the first version that was made in D3, and I'll show you what that looks like. So X3DOM is doing the bulk of the work. I'm just letting it know what to render. And you can like switch around through all these drop-downs because hashtag Bootstrap. And yeah, it just gives you a lot of different polyhedra that you can play with and look at. And this was version number 1. So I made it, and it was like, this was just a slide to show you what it looks like if the internet didn't work. So this is what it looks like, and I thought, okay, I made this. Congrats to me. I have completed my polyhedra decks, and now I am. Yay, I can move on to like another project and can finally learn about like this Bitcoin thing that everyone was interested in. But I was left feeling a little bit unsatisfied. This project, as you can tell by how little you reacted to it, did not bring me that much joy, or you that much joy. And it's kind of similar to stuff I've seen on the internet. It was very simple. So 2 years later, I kind of got back to it. And the reason I got back to it was because at work, we were trying out this fancy new thing called like React. This is like some obscure JavaScript framework that no one knew about, but we're switching to it, and we're also using Redux. So I thought, hey, I want to be a good little employee and try to learn about it before I actually start working on it. So I decided to go back to my project and update it, and it turned out to be pretty well. X3DOM is a declarative library, and React is also declarative, so it kind of fits nicely, and you can just write your 3D scenes in React. You can write entities or components of those 3D scenes, and then you can just hook them up together. And it works. And I added some more things. I added like a config panel, because you need to use Redux for something. I added like a list with like filtering, because again, you need to use Redux for something. And finally, I added an index page so you can actually see the different polyhedra all in one place. I can look at this and yes, here is my collection of different shapes. You can see that one over there is my favorite. So this is version number 2, and I made it, and I thought, okay, now I'm done. I'm done. I can finally move on and learn about what else. Machine learning, is that still a thing? But it was still kind of unsatisfying because, again, there's still nothing about this that's unique to Polyhedra or their relationships. I can literally replace it with a 3D Pokemon model and it'll still be the same app. So I was still kind of unsatisfied by it and kind of wished that I had something better. A little bit later, I left that job, and I was thinking about having a project to tide the time over, and I ended up going back to this diagram, and you're saying all these related polyhedra have the same symmetries, they have the same operations or functions on different atomic polyhedra, generate different ones in the series. So I thought, well, if they're have this very nice and ordered form, maybe I could arrange them in some sort of chart or table, and what if you just call the rows periods or something? I don't know where you would get that idea, but that is what I ended up doing. I turned it into essentially a periodic table of polyhedra, and now this is starting to get to where I want it to go. Everything is organized. You got a sense of the relationships, but by looking at the different rows and columns, and you can see that, okay, as you go down a row, you're adding a side, but when you're going across a column, you're doing the same operation to a different base. But this is still really static, and because I was using React, I realized, well, I could do so much more. I'm still not taking advantage of it. And then it hit me. I was browsing through Wikipedia, like you do, and I looked at this animation. And what's happening is that this is a cube that's turning into an octahedron and then back again, transforming and undulating. And I thought, hey, maybe this is dynamic. You are seeing the relationships between dual polyhedra. And I thought, well, what if I made this but for all the polyhedra? That shouldn't be too hard. Turned out to be pretty hard. Took me about 7 months to do. But let's get into how exactly I did it. So first of all, you want to draw lines between the polyhedra that are connected somehow. If you can transform a polyhedron to another, they are connected by an operation. And so when you see nodes and lines like this, what you have is a directed graph. And that's exactly what I have. I have polyhedra as nodes, operations as edges, and I have different labels with metadata to differentiate between multiple results. But I also had a lot of polyhedra, and I didn't want to hand code 120 different node graph. So I already had the data that was used to generate the table that was being shown. And so all I needed to do was take a transform function to change the table layout into the graph data structure that I needed. And it's kind of backwards, but it works. And I really just wanted to get to the good stuff, which was the actual animation. And so looking at this again, how does one code something as complicated as this? You can see that faces are being added and removed. And added back again and then removed again. And you want to do this for all polyhedra. So maybe for this one thing, you could duplicate and have extraneous faces that are very, very tiny when they're not being shown. But you want to do it for all of them. And so you need to smoothly transition. And adding a bunch of duplicated stuff doesn't work. So this was kind of the algorithm that I kind of came up with. First, you want to switch out the old polyhedra with one that has these stub duplicated vertices and faces, and then you want to interpolate from that duplicated version from the initial state that looks just like the old polyhedron into one that looks like the polyhedron you want to end up looking like. And then finally, you deduplicate the vertices and faces if necessary, if any of them basically disappear from the transition. And then you switch out with the pure version that doesn't have the duplication so that that is ready for the next animation. And this may seem like a lot, so let's go into an example about how this works. Here's an operation called rectification. And what it essentially does is you're taking off each corner of this cube or each vertex and like chopping it off right in the middle to create a new triangular face in between. And the thing you get into, the thing it transforms into is called a cube octahedron. And to see this in detail, you start with a cube, you mark each of the midpoints of the edges, you draw a line along all of them, you take each vertex and you want to copy it twice. You want to move each copy into one of the midpoints. And again, you want to do this for all of them. And finally, you want to take, you'll notice that there are, for each like green dot where the points should end up, there's like there are two vertices that end up there. So you want to consolidate them and duplicate them so that the final thing like has no extra vertices or faces. And you end up with this thing. So to recap, you duplicate, switch out, interpolate, deduplicate, and then switch back in. Easy. And the thing is, like, you can abstract out the apply operation function. So whatever transformation you want to do, it's the same pattern of taking an operation and a solid and like whatever options you need, and then like do fancy math, and then you spit out this thing called an operation result, where you have the copy that has duplicated vertices and faces. You have the end points of those vertices, but with same faces and edges. And then you have the result that is like deduplicated. So how does one actually implement this transition in React? So first of all, I kind of tried like React Motion, which I was using in the old version for like another UI animation. But it ended up being pretty hard because this algorithm was fundamentally imperative. And whenever I tried to like work with the declarative syntax, like I got into a lot of issues where I had to like create new elements and like decreate them, and it was just like really annoying. So like maybe not React Motion, but maybe like another animation library that was kind of more traditional and imperative, like Anime or GZAP. I mean, I wrote this slide like a week ago, and these libraries are probably all dead, because that's how fast animation in JavaScript goes. But I ended up making my own instead. Yeah, I know update request animation frame. I am cool, like the Squirtle. But the thing about like making my own thing is that it let me have an exact translation of that algorithm that I mentioned. Here, you are just setting state to the duplicated start. You are transitioning, interpolating between the start and the end, and then you're setting it to the deduplicated result. And because I was making my own function, I could like define just the exact callbacks I needed, the exact API I needed to make this work for this one thing that I'm only using in this one place. But in the end, let's see how that actually works. Ooh. OK, so repeat 14 times, because that's how many operations I have. But we're not actually going to go through all that, because it's just like a bunch of math. And like I said, you can pretty much abstract it out to a single interface. And I'm going to leave this as an exercise to all of you who are math nerds. And I'm going to talk more about like the interesting things that I came across, both the good and bad, while I was making this project with React. So remember when I said that X3DOM and React like went together like really well? Not really. It kind of did not work together well, and the reasoning was because X3DOM is a really, really old JavaScript library, and like it doesn't support CommonJS or anything like that. So it just like puts the X3DOM name onto the global namespace. So I had to use like exports loader syntax from Webpack in order to like get it to work. And that was like fine for the old version, but then I was like, well, this new thing is like kind of really big. I want to write tests for it. Well, it kind of messed up the tests because like just and enzyme don't understand like export loader syntax. So then I was like, oh, okay, I'll just like, if my node enters test, then like I'll load a stub. Otherwise, I'll use this export loader. And then the thing about that is that 3D libraries are like really, really big. And so whenever I did that, whenever I had this conditional, it would just like load the library twice, which was like sucky for my package size. So like in the end, I just like extracted it out to like a utility adapter library, and then like I had to create a mock on the tests, make a mock, and then whenever I imported it, I had to do it from like my stub instead of from the actual thing. And you may be asking, why don't I just like eject create React app in order so I can actually use like Webpack components and stuff? But that's a good question. I don't know the answer to that. But a more fun problem I had is that sometimes you can evolve Polyhedra, in more than one way. So here you have what is called an augmented hexagonal prism, and when you want, you can add another pyramid to it, either like across from the one that already is there, or like adjacent to it. So how does one do it? Well, there is a native there is an easy UI that you can think of, which is just whenever you hover and click on a certain face, it'll add the pyramid to that face. Also, this is really similar to this. But so I was looking at Xfreedom, and I was thinking, does this support it? Well, it kind of does, and it says, oh, just add an on-click handler to your shape and put in the string expression that you want executed. So I tried that, and I was like, this should work, right? So that did nothing. And so if you prefer pure JavaScript, or if you're not using a dumb old library, like you can do a document.onload, and then you can add the events manually. So I ended up having to do that. I have a handle load function, and then like that attaches the on mouse move and on my mouse click on click events, and I had to like attach it to the document, and I had an event listener component that did that because hooks didn't exist yet. But and I also need to call like once lodash.once, which makes sure the function executes only once, so that because otherwise like the handler would get called like multiple times, and that ended up being really weird. But again, the test failed because since I'm adding it manually and it's not actually a prop on the object, and enzyme doesn't know about it. So I had to end up adding it anyways, and the note says that these are duplicated to make it easy to test on enzyme. They don't actually do anything in production, but it works. And as you can see, you can click on the different faces or hover over them and click them, and you have your augmented hexagonal prism. And so here are some of the ways that I kind of struggled with. But here are some of, whoops. God. But let's go talk. Let's talk about some of the good parts of React and not worry about the bad parts of presentation software. So I started thinking, like this Charizard, about, I was working on this project like pretty much like full time after I left my job, and I should like actually release this and make a big deal about it and put more effort into the design. The thing was that all of these Polyhedra websites that I used to go to as a kid are very, very old. They're not very aesthetically pleasing. They mostly have like basic HTML. If they had like 3D models at all, they would usually be in this like really old file format, like called like vermal, that nothing ever supports. And I wanted to create something that was more accessible, even if you didn't know about Polyhedra. With all these, like if you don't know anything, it's already going to be like, it's not going to, like if you saw the site and was like, oh yes, Polyhedra, that's the thing for me. No, you're not going to do that. So I wanted to make a site that did that. And one thing that I realized was important was mobile. And it was kind of a selfish reason that I decided to do it. Basically, I would show the prototype to friends, and then they would be like, oh, I'm sorry, I'm on my phone right now. I'll check it when I get home to desktop. But then like they'd never do that. So I was like, all right, this is going to be on mobile. So the good thing about React is that you can just make those basic components and then use different components to lay them out either for a desktop view or a mobile view, and just like switch between them based on like the viewport width or whatever, which I did, and this is what it looks like. So the config panel that I had in the previous version gets moved to a sidebar in the desktop version, and then in mobile, it is overlaid onto the actual solid so that you can edit stuff and still see the effects in real time on the solid below. And these are all like very basic components that are just laid out differently based on whether the toggle is set to mobile or desktop. Another thing that I really wanted was icons. Initially, all of the different polyhedral operations were just text, but like no one knows what the word gyro elongate means. So I wanted to make sure that people understood. Like even when I added popovers with like descriptions, no one would ever actually read them. So I wanted to make big loud buttons that said, that kind of told you what it did. So the gyro elongate button, like there's zigzag things, so it says like, okay, it does some sort of like zigzaggy, extendy operation on the base polyhedron. But the problem was that these are a lot of icons, and I didn't want to use Sketch, and because like I have to make them in Sketch, and then like if I wanted to change it, I have to like update all of them, and then like import all the files again, and it's going to be a huge hassle. And then I realized I can just do this in SVGs in React, and it took me about a day to do. And here they are, my nice little icons. They're highlighted based on which operations you can do. And next, remember this thing. So I kind of realized that horizontal scrolling was also like kind of weird on mobile. It's not very mobile friendly. And also, I kind of wanted more information to be on the front page. I was kind of inspired by these long interactive articles, like the Parable of the Polygons by Nikki Case and by Hart, and Shirley Wu's Hamilton visualization that she made in D3. And I wanted something like that, so I started writing a bunch of like definitions and explanations, and I realized that, man, I have like a lot of lists on here. I have a lot of like italicized, unique math definitions and stuff, and I really wanted to write this like without any HTML. Turns out there's a React Markdown library, and I could do that. And so here's what the front page looks like. There's a masthead. There's like a table with kind of the tables from before, just like laid out vertically. You can click a read more button and show more text, but it's like all collapsed because you want to. The main point is for you to click on the polyhedra and go to the actual stuff. And also, like I wanted to make it look good on mobile, so I had to do some clever stuff like splitting off tables depending on whether you're on portrait or landscape orientation. So without further ado, here is the little app. So here it is. There's like an animation on the masthead to kind of clue you into what the app does and the full functionality. So let's just pick a cube. And remember that Wikipedia animation from before? Oh, wait, that was the wrong one. That was the one that we showed earlier. Well, we can do that Wikipedia animation and expand it. We can contract it into another thing. And it doesn't only work for this one thing. You can choose another polyhedron and do the same thing. You can do a lot of different operations like gyrating and like twist the little faces, or you can like get rid of them if you don't like them, like this one. No, no, no. And let me see what. And also we have like the options panel from before. Whoops. And you can change them, and the colors change as you're animating, because each color is associated with a different type of face. So that's pretty cool. And how do I go back. Yeah, so it's live right now, so you can like, so you can look at it instead of listening to the rest of my presentation. But which is okay because it's basically just me bragging about how cool my thing is. So I posted it on Twitter. Like I got a lot of retweets from like Vsauce, which is like a science YouTuber. I got interviewed by a math periodical. Like my follower count shot up from like 0 to a nice number. And another important thing is that I noticed is that about 40% of people use mobile. And that's cool because it validated me deciding to actually make it using mobile. A lot of people don't, especially those with low income or thinking about like children that only have access to their parents' like iPad or something, don't have access to desktops. And if you're ever thinking of making something educational or informative like this, it's important to make sure that it actually is for everyone. And something like that's cool about a component framework like React is that it makes this kind of switching easy. My best piece of feedback was an email I got from someone saying that my 4-year-old child spent 7 or more minutes playing with it, choosing different base polyhedra and transforming them without asking for my help. Usually he asked me too many questions. So essentially, without knowing what the word gyro elongate means, this kid was able to play around with it and explore, and I may have like instilled in him a lifelong love of polyhedra, and like 20 years from now, he's going to make a brand new version of this using React number 700 or whatever, and it's going to be 5 dimensions, and it's going to be awesome, blow mine out of the water. But for now, I consider my job done. I'm going to see. Yeah. I'm going to leave you with, like, this is something that I've been working on for a long time, iterating as I go along and changing up libraries and stuff. And yeah, having the right tools really lets you do more and take your passions and bring them into life. I'm going to skip through these slides because I'm running out of time. But even though I say that I am done with them, I'm never going to be finished with them. Like right now, as soon as this is done, I'm going back and refactoring everything to use hooks. But yeah, that's my presentation. And if you, here's the link again. Here's my Twitter. And I had to skim over a lot of stuff because this is only a 30-minute presentation. But if you want to look into a deeper dive with like all the math stuff for you nerds out there, I am writing a series of blog posts on making this app. All right, thank you.